Hi, I'm Dr. Kian. We are here to discuss wave nature of particles. Under this topic is wave theory. Wave theory is that light is propagated through the ether by the wave motions imparted to the ether by the molecular vibrations of a radiant body. So what is wave? In physics, a wave is a disturbance that interferes energy through the matter or space. With a little or no associated mass transport, waves consist of oscillations or vibrations of a physical medium or a field around relatively fixed locations. There are two main types of waves, the mechanical and the electromagnetic. Next to this topic is wave sound principle. The behavior of the sound waves as they travel through the medium or reflect from an object can be found using a remarkable, simple, geometrical procedure by Huygens principle. This principle describes how wave fronts move. A wave front is a surface consisting of all points on a wave at the same position in a wave cycle. For example, all of the points located at the crest of the same wave form a wavefront. Similarly, all of the points located at the true of the same wave form is a wavefront.
5 minutes later.
Moving on, we have Huygens principle, the first person to explain how wave theory can also account for the laws of geometric optics was Christian Huygens in 1670. At the time, of course, nobody took the slightest notice of him. His work was later discovered after the eventual triumph of the wave theory. Huygens had a very important insight into the nature of wave propagation, which is nowadays called Huygens principle. In Huygens principle, we have straight wavefront. Applied to a straight wavefront, each point on the wavefront emits a semicircular wavelet that moves a distance s equals to vt. The new wavefront is a line tangent to the wavelets. We're going to show a figure. The figure shows a simple example of the Huygens principle of diffraction. The principle can be shown with the equation S equals to Vt. S is the distance, V is the propagation speed, and T is the time.
Next.
The Broglie wave. The hypothetical wave train that in wave mechanical theory responds to a moving elementary particle such as electron and protons. Move with it and it gives the particle certain wave properties as interference and diffractions. Wave nature of particles. In experiments like the photoelectric effect and Compton effect, radiation behaved like particles. De Broglie, a French physicist, asked whether in some situations the reverse could be true. Would objects which are generally regarded as particles or electrons behave like waves? In 1924, de Broglie postulated that we can associate a wave with every material object. In analogy with photons, he proposed that the wavelength of lambda associated with just a matter wave is related to the particle momentum, which is p, through the relationship lambda equals h. It's a Planck constant all over p. And now Dr. Sempio will show you a sample problem in matter wave.
A few moments later.
Hi guys, I'm back. So this is the sample problem in our topic, wave nature of particles. So here we're going to calculate the wavelength associated with a quicken ball of mass 0.2 kg moving with a speed of 30 meter per second. So how can we get the wavelength? How can we get the wavelength? So first, we're going to get the particle momentum. The particle momentum is equal to mass and velocity. So we're going to substitute the mass, that is 0.2 kilogram, and then the velocity, that is 30 meter per second. So P is equal to 6 kilogram meter per second. So after that, makukuha na natin yung wavelength. So substitute lang natin. Then wavelength is equal to Planck, that is constant, and particle momentum. So substitute the Planck's constant, that is 6.63 times 10 raised to negative 34 joule seconds, and all over the P, that is 6 kilogram meter per second. So the answer will be 1.1 times 10 raised to negative 34 meter. That's all.
Going back.
Thomas Young, wavelength theory of light. We had to overcome the century-old view expressed in the venerable Isaac Newton optics that light is a particle. Nevertheless, in the early 19th century, Young puts forth a number of theoretical reasons supporting the wave theory of light, and he developed two enduring demonstrations to support this viewpoint. With the ripple tank, he demonstrated the idea of interference in the context of water waves.
So hi guys, so bago kami mag-start ng aming P6, so kakain muna kami ni Kian. So kasama namin si Philip tsaka si Jana. Hi. So ayun, naglalakad kami ni Kian papuntang Chowking kasi kakain kami. Tapos
Ano daw?
di namin alam kung babalakin pa namin. Babalakin pa ba namin gumawa ng P6? Bakit? Dalawa lang kami. Nababaliw na kami, tapos di pa kami marunong mag-edit ng video. Alam mo yun?
Grupo namin, bakasyon na sila. So, kami lang talaga nagdadamayan.
Totoo yun.
Hindi ko alam kung anong gagawin na.
Mabubuhay pa ba kami? Mukhang babagsak namin sa P6. Hindi na kami makakagraduate. So, babalik na lang ulit mamaya.
1 hour later.
So, we're back. Kakatapos lang namin kumain. So, guys, babalik na kami ng annex at gagawin yung P6. Di ba, Kian? Kailangan sa P6. So, ito, naglalakad na kami. So, papunta na kami ng NU Lab. So, mamaya na lang ulit.
5 minutes later.
Na kami sa NU Annex Building. Nasa 4th floor na kami, naglalakad na kami papuntang room. Tapos ito, naglalakad kami, umakit kami. Uy, magkatumakbo!
Bilisan mo, kailangan na natin gumawa ng V6.
Gagawin na namin yung P6 kasi naubusan na kami ng oras. Alam mo ba yun?
Medyo kailangan bilisan.
So, ayun, nandito na kami sa 6th floor. Papasok na kami ng room. At welcome to Jollibee. Nandito na kami sa room.
Mga tanga.
Gagawin na namin yung aming P6. So, hi guys! Welcome to our vlog!
Lupit doon!